All right, welcome everyone. Today, we're going to dive into one of the greatest stories ever told, humanity's journey to the stars. It really is a tale of brilliant minds, incredibly daring adventurers, and a collective dream that literally took us from our home planet to the surface of another world.
This is the big question, isn't it? For thousands and thousands of years, humans have looked up at the night sky and just wondered, what's out there? It's this deep, innate curiosity, that need to see what's over the next hill, that has always driven us. And in the last century, we finally built the tools to go find some answers.
So, here's our roadmap for today. We're going to start with the early dreamers, the people who first imagined all of this. Then we'll blast off into that intense space race. We'll watch that giant leap to the moon, see how we built a home in orbit together, send our robotic detectives to Mars, and finally, we'll explore the incredible new space age that we're living in right now.
Every epic journey doesn't start with a single step, it starts with an idea. So let's meet the visionaries who first proved that leaving Earth wasn't just some sci-fi fantasy, it was actually a mathematical possibility.
Okay, so here you have the two essential halves of any great invention. On one side, there's Konstantin Tsiolkovsky, the theorist. He was the one who did the math. His famous rocket equation was the blueprint, the proof on paper that we could actually escape Earth's gravity. And then on the other side, you've got Robert Goddard, the practitioner. He's the guy who took that theory and made it real, launching the world's very first liquid-fueled rocket from a quiet farm field. One dreamed it, the other built it. You need both.
So, what exactly did Goddard build? A liquid-fueled rocket. Isn't like a firework that just goes bang and it's done. No. Think of it more like a super sophisticated, controllable engine. You're mixing a fuel with an oxidizer, and because of that, you can control the power. You can throttle it up, throttle it down, you can even steer with it. This gives you that sustained, powerful push, that thrust that you absolutely need to defeat gravity. That control was everything.
All right, so the theory was there, the basic technology was there, the stage was set. And then the Cold War turned space into the ultimate competitive arena. It sparked a race that would push human progress forward at an absolutely breathtaking pace.
Just look at how fast everything happened. On October 4th, 1957, the world completely changed. A little metal sphere, just 58 centimeters wide, named Sputnik, started circling the globe, sending out this little beep, beep, beep. That sound announced the dawn of the space age. And get this, less than 4 years later, a human being followed it into orbit. Sputnik wasn't just a science project. It was a political earthquake that led directly to the creation of NASA and lit a fire under the race to the moon.
For 108 minutes, just think about that. For 108 minutes, Yuri Gagarin was the only human being in the entire cosmos. Can you even imagine the bravery it took? His single orbit proved that a person could survive and function in weightlessness. He became an instant global hero, the living proof that this dream was now real.
So, with low Earth orbit now conquered, the world set its sights on a goal that was almost mythical in its ambition: the moon. This was going to be the ultimate finish line in the space race.
This date is just one of those moments where all of human history pivots. On this day, our species' footprint was no longer confined to just one world. We officially became a species that had walked on another celestial body. Just incredible.
And with those unforgettable words, broadcast from the surface of the moon to a planet that was holding its breath, Neil Armstrong just perfectly captured the meaning of that moment. The Apollo program wasn't just about technology. It was a profound statement about what we as humans can achieve when we dare to dream on a planetary scale.
Now, after the sheer intensity of the race to the moon, the focus of space exploration started to shift. The next great leap wasn't about going to another destination, it was about a whole new way of thinking, moving from competition to cooperation.
You can really see that shift right here. Back in the 1970s, it was all about building your own space station. The US had Skylab, the Soviets had their Salyut stations. They were amazing national accomplishments. But toward the end of the century, a new idea started to take hold. What if we built something together?
And the result of that idea was the International Space Station. It's this massive, orbiting laboratory built and operated by a coalition of former rivals and new allies. I mean, the ISS is as much a triumph of diplomacy as it is a masterpiece of engineering. For more than 2 decades, it's been this incredible symbol of peaceful collaboration, circling 400 kilometers right above our heads.
So, with a permanent foothold in orbit, our curiosity naturally started to look outward to that enigmatic red neighbor of ours. But this time, we sent our robotic pioneers to check things out for us first.
Okay, so rovers like Perseverance, they are so much more than just explorers with cameras. They're basically robotic geologists and astrobiologists working on a planetary cold case. They were sent to Jezero Crater for a very specific reason. All the evidence tells us it used to be a river delta filled with water. So Perseverance isn't just looking at pretty rocks, it's hunting for clues, for ancient biosignatures, the little chemical fingerprints that life might have left behind. And it's carefully collecting the most interesting samples to be picked up later and brought back to Earth.
And as if landing a science lab the size of a car on another planet wasn't impressive enough, the mission also delivered this, a genuine Wright brothers moment on another world. The Ingenuity helicopter proved that we could actually achieve powered, controlled flight in that incredibly thin Martian atmosphere. It was an amazing tech demo that opens up a whole new way of exploring other planets.
And that brings us right up to today, where the entire landscape of space exploration is going through another huge transformation. A whole new set of players has entered the game.
Yeah, this chart really shows the evolution. We started in an era that was completely dominated by governments. Think Apollo. Then we moved into a time of public-private partnerships, like having private companies deliver cargo to the ISS. But now we're entering a future where private companies like SpaceX and Blue Origin are building their own rockets and launching their own missions, which is dramatically lowering the cost and increasing access to space for everybody.
And all of this new energy is being focused on the next giant leap, making humanity a multi-planetary species by setting up a permanent presence on Mars. But wow, the challenges are just immense. We have to figure out how to protect people from deep space radiation, how to create breathable air and grow food millions of miles from Earth, and how to learn to live off the land, using Martian resources to build and to survive. So that's our story so far. From a little beeping satellite to flying helicopters on another planet. It's a story of curiosity, of intense competition, and finally, of collaboration. And as we finish up, we're left with the one question that will always define our future. The great story of exploration is never really over. The next chapter is just waiting for us to write it. Thanks for joining me.